Next, we will demonstrate operation of how the electromagnet causes the electrical contacts to open and close. In order to do this, we must supply a 12-volt power source across terminals 85 and 86 to energize the electromagnetic coil. For demonstration purposes, we will use the relay with the cover removed so we can see the mechanism in action. Conductors have been installed at terminals 85 and 86 at the relay. The positive conductor is now attached to the positive terminal of the battery. Now when we touch and release the negative side conductor to the negative battery terminal, we can see the electromagnetic coil attract and release the switch contact in the relay. We will now demonstrate another way to test the operation of the electrical contacts inside the relay. If we measure for continuity with an ohm meter between terminals 30 and 87, while opening and closing the contacts, we should measure low resistance when the contacts are closed and open circuit when the contacts are open. As we did before, we will open and close the relay by energizing the coil with a 12-volt battery source. With our multimeter set to ohms, we will first test to see if the meter reads continuity properly. With our relay low current control side terminals still hooked up to the battery source, we will now place the leads of our meter to the high current side terminals 30 and 87. As we energize and de-energize the coil, you can see the meter reads low resistance when the switch contacts are closed, and open circuit when the switch contacts are open. This would indicate good operation of the relay. If we happen to measure high resistance when the contacts were closed, that could indicate damage to the electrical switch contacts of the relay and would warrant replacement of the unit. Another test we can perform on the relay is to measure the resistance of the electromagnetic coil itself. Using an ohm meter with its leads contacting terminals 85 and 86, we should expect to see some resistance. The service information for the relay in question may provide a range of acceptable readings, but more often than not, we have to interpret the readings ourselves. It is typical for a relay's electromagnetic coil to have between 50 and 200 ohms resistance. If your reading is outside these typical readings, the coil may be faulty and would warrant replacement.